Welcome to qnawire.
In question 9, we have to deal with this Cope-Douglas production function, which is y equals to a times k to the power of one third, and L times 2 to the power of L to the power of 2/3, where Y means production and A is a parameter, K is capital, L is labor. So we know that the marginal product of labor is just this Y take derivative with respect to L, and we already got the answer here, which is 2/3 times A times K divided by L to the power of 1/3. All right, and we just have to plug in all the numbers here. So we know P, the price of the output, is 2, and A is 3. This is just a parameter. And K is 10 to the power of 6, 1 million. And then L is 1,000, so 10 to the power of 3. All right, so with all these numbers, we can answer question A. Question A, calculate the amount of output produced, so calculate Y, and the dollar value of output, PY. So to calculate Y, we just have to plug in A, which is 3, because here we have A, so this is A times, what is K to the power of 1/3? So that is going to be 10 to the power of 2, because 6 divided by 3 is 2, right? And then L to the power of 2/3, which is 10 to the power of 2. Okay, so the Y here is 3 to the power, okay, I'll just write 30,000 here. So 3 times 10 to the power of 4, right? And what about the value? So we time this output amount by the price here. So it is going to be 60,000. All right, question B, calculate the wage and the real wage. So what is the wage here? We know that the wage is going to be the value of marginal product of labor, which is P times MPL. So we have to calculate this MPL in this setting. So 2/3 times A, which is 3, times K divided by L is 10 to the power of 3, right? So 10 to the power of 3 times 1 to the power of third, which is just 10. So we know that in this question, the MPL is 20. So since we have MPL, we can calculate wage, which is P is 2 times 20, which is 40. So the wage is 40. What about the real wage? So the real wage is wage times divided by the price of the economy, which is equal to just the MPL here. So the marginal product of labor is equal to the real wage, which is 20 in this case. All right, question C, calculate the labor share, which by definition is W times L divided by P times Y. So labor share is how many proportion of the value output is devoted by labor. So we already have this W, which is 40, and 40 times labor, so I'll just write 40 times 10 to the power of 3. So divided by py, what we already have is here. So it is 60 and also to the 10 to the power of 3. So the labor share is 2/3. Right, so question D, calculate what happens to output wage, the real wage, and the labor share in each of the following scenarios. So first, if inflation increases P from 2 to 3, so now we have 3 here, right? So when we recalculate this P times Y, we see that since output is A times K and then L, it has nothing to do with P. And MPL also has nothing to do with P. So even if price changes, these amounts won't change. But what changes here is that it is going to be 3 times Y, right? So 3 times Y is 90,000. So wait a second. So in this new scenario, we know that the wage doesn't change, right? Because I'm sorry. The wage did change because what doesn't change is the MPL here. So P now is 3. So it is P times 20, which is 60. So now we can calculate this ratio. So wage is now 60, right? And then L doesn't change, so I just remain the same. And then PY becomes 90 to the power and then 10 to the power of 3, right? So we can see that the labor ratio is still the same. Why is it the case? Because inflation increased the price, so it also boosts the wage proportionally, while in terms of real output, it doesn't change. Okay, what about technological progress increase A from 3 to 9? So we now take a look at what if this A change. So if A change from 3 to 9, I think I have to add another page. It's a little bit messy. So now our goal is to calculate this labor share, right? So if we write down everything, we know that this W equals to P times MPL. P times MPL. So times L and then divided by P times Y. So actually these P appears in denominator and numerator, so we can just cancel them out. So what we really care about is this ratio. And from this previous slide, we know that MPO equals to this. So I will just further plug it in, which is 2/3 times A times K divided by L to the power of 1/3 times L. And then divided by, I also write this K out, A times K to the power of 1/3 and then L to the power of 2/3. So if we further simplify this term, we can see that it is actually just 2/3 because A cancels out, this 1/3 K cancels out, and then L is also 2/3 cancels out. So no matter what happens to to this economy, the labor ratio is always the same. So as we just calculated as an example, that when inflation um, changes, the labor ratio is the same. So similarly, if we increase this A from 3 to 9, it is also not going to affect this labor ratio because A cancels out. So when capital accumulation increases K from something to another thing, it also won't change the labor ratio because K also cancels out here. Okay, so now we can answer question E. Despite many changes in the economy over time, the labor share has been relatively stable, which is one phenomenon we try to emphasize in this exercise. So, is this observation consistent with the Cope-Douglas production function? Well, yes. So one of the key feature of the Cope-Douglas um, production function is that the labor share is always 2/3. This 2/3 appears in the original production function. So the labor share we can just observe from this production form is 2/3, while the capital share is 1/3. This is the key feature of the Douglas function.